Here's some examples of using the distributive property to calculate expressions involving multiplication and addition. Suppose we want to calculate 25 times 32. So we could use the methods from the previous video and multiply that out using either partial products or the common method. Alternatively, we could recognize that we can write 32 as 30 plus 2. And then if we apply the distributive property, we can rewrite this as 25 times 30 and 25 times 2. And 25 times 30, well, 3 25s would be 75, and so 30 times 25 would be 750, and then 25 times 2 is 50, and so we get the final answer 800. So there we've used the distributive property to do that calculation, maybe a little bit quicker than using the partial products method or the common method to multiply it out. Here's another example. Let's do 25 times 39. So this time let's write 39 as 40 minus 1, because then I can write 25 times 40 minus 25 times 1. 25 times 40 is 1,000. 25 times 1 is 25, and I quickly get the answer 975. Let's do one more. This one's a little bit different because it's an addition problem, and it's the kind of addition problem where you might make a bunch of arithmetic errors and get the wrong answer. So instead, if we recognize that 7 is a common factor for each of those numbers, so 7 times 7, 7 times 8, and 7 times 5. So if I pull out that common factor and then use the distributive property kind of in reverse, I'll have 7 times the sum of 7 and 8 and 5. And the sum of 7 and 8 and 5 is 20. And now I can easily do 7 times 20, that's 140. So there's 3 examples of using the distributive property to do calculations involving addition and multiplication.